All right.
All right.
No Mr. Richard today, so let's take a look at a couple problems together and then we'll do some homework. First thing I wanted to look at was ask if there were any homework questions. And then I wanted to make sure that we looked at number 104, 105, and 106. I'm assuming you have because we all do homework. But if not, let's familiarize ourselves with number 104. We know that 0.33333 has always been equal to 1/3. But I think it's a pretty cool little proof here that they just kind of basically walk us through. So I'll pause each time, and I'd like you to kind of just walk yourself through it. So if n equals 0.333, repeating, what would 10n equal? Well, we would just move the decimal one place, so it'd be 3.3333. And then as we fill in the blanks, we've got 10n equals this, and we've got n equals 0.3 repeating. And then part C asks, what do you get if you subtract? So it's kind of like what we've looked at with those geometric sum problems. If we subtract, of course, all of this goes away. 10n minus n would be 9n equals 3. So if I want to know what n is as a fraction, it's going to be 3/9, which is, of course, if we simplify, 1/3. So using the same technique, let's look at 105 and 0.5 repeating. So what does 10n equal? 5.5555 minus n, 0.5555. So 9n equals 5, n equals 5/9. Check it on your calculator. 0.5 repeating, good to go. So we should probably start seeing a pattern here. Try B and C. Of course, use your calculator again. And then also try 106. If you're interested, check the answer in the back of the book. If there's any other homework questions, of course, we can go through those tomorrow. But I would strongly encourage you to familiarize yourself with 110, 111, and definitely 113. All right, let's take a look at 8, 2, 4. What does 1 plus 1/2 plus 1/3 plus 1/4 plus equal? All right, so yesterday we talked about an infinite geometric sum having a finite sum. So today we're going to investigate the behavior of a special series called a harmonic series, 1 plus 1/2 plus 1/3 plus 1/4. The name of this series comes from the concept of overtones or harmonics in music, so orchestra kids. The wavelengths of the overtones of a vibrating string are 1/2, 1/3, 1/4 of the string's fundamental wavelength. So we're going to begin by investigating some simpler but related series. So 114, as we read it, says find the sum of the infinite series below, where you have 2 quarters, 4/8, 8/16, etc. So as we write it out, 1 plus 1/2 plus 2 1/4 plus 4 1/8 to infinity. What would that sum be? In my mind, my explanation would be if I have 1 plus 1/2 plus 1/2 to infinity, it's got to equal infinity. My thinking would be, how long would it take to get to 1,000,000? It would probably take 2,000,000 to get to 1,000,000 because we're adding infinite halves, but it would grow to infinity. There's no r like we had yesterday. We're not multiplying by a constant number that's making the number smaller and smaller. All right, looking at 15. Now calculate the sums of the first few terms of the harmonic series by finding sigma notation from n equals 1 to k of 1 over n. So just looking at A, let's go from 1 to 10. So that would be 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 10. What do we get when we add that up? Well, 1, 1/2 plus a third. I get, when I type it in my calculator, 2.929. So we are getting bigger. Now let's try it when we type in 20. I get 3.598. Type in 100. 5.187. Type in 500. I get 6.793. So it's growing, but it's definitely growing. We put in 100 here and 500 here, and it didn't get that much bigger. So my challenge for you would be, use your calculator and tell me what value of k would get a sum greater than, let's go with 10. And then go ahead and put your answer in. And 116, we want to prove, go ahead and read it, we want to prove that from n equals 1 to infinity of 1 over n, it is in fact infinity. We looked at it in 115. It was growing slowly, but it was growing. So do we think it's going to have a limit, or is it going to be infinity? So we're going to try to prove that it equals infinity. So as we look at fact 1, suppose that s equals the sum from 1 to infinity of s of n, and t equals the sum from 1 to infinity of t of n. Our two series, and s of n is less than or equal to t of n for each n, and then s has to be less than or equal to t. In 8.1.14, we showed that other series of 1 plus 1/2 plus 1/2 plus 1/2 equals infinity. So what do you think fact 1 means? I think by definition, if it says s of n is less than or equal to t of n, and we're adding up infinite s's and infinite t's, then infinite s's should be slightly smaller than infinite t's. Which kind of makes sense in my mind. So therefore, if I have some 1 over n squared plus n, that must be less than or equal to the sum of 1 over n squared. N is a term number, so it's going to be a positive integer. So therefore, 1 over n squared plus n has to be bigger than or equal to 1 over n squared. Now, I would like you to take a second and do 117. Write out the first 15 terms of the sum we want to look at. So 1 over 1, 2, 3, 4. So if you were to write out the first 15s of 1 over n, and then the first 15 terms of our problem from 114. So the cool thing that mathematicians use when looking at things like this is that they're very similar. They're equal here. But what happens here? This guy's bigger. The first one is bigger here. They're equal here. And then the first one is bigger here. So we already said that that first one goes to infinity because it's 1 plus 1/2 infinity times. And from fact 1 and fact 2, we should be able to conjecture that because this one is bigger than, so we'll call that one t, is bigger than or equal to s, therefore the sum has to also be bigger. So therefore, we can write that from 1 to infinity of 1 over n is in fact infinity. Take a second. I'd like you to write a couple sentences for 117 explaining why. If you just want to summarize what we just said, go back over the video, probably not a bad idea. And then I always like our question in E. If that's infinity, then what is this? And the answer, of course, is not infinity minus 1. The answer is infinity. All right, and then I would like you to, in your teams, discuss 118, 119, and 120. And if you need to wait for a neighbor to get done, I would suggest maybe looking at homework problem, probably number 129. I think that's a very good one to familiarize yourself with. All right, see you tomorrow.